So, this is a review of a few of the concepts that are covered in Chapter 8, and it's not everything covered in this chapter, and it's certainly not everything that will be covered on Test 3, but it's a few of the high points. So, in this and the next chapter on minerals and water, we'll conclude our study of the 6 classes of nutrients. Now, one thing I wanted to note before we get started is in both Chapter 8 on vitamins and Chapter 9 on minerals, there's an abundance of information that can seem pretty overwhelming. You'll definitely want to focus on knowing the classification of vitamins, such as whether or not they are fat or water soluble, the vitamin's general roles in the body, good food sources for each vitamin, and what complications could arise if one has a vitamin deficiency or a toxicity. These are covered in the individual sections in the textbook, and there are also infographics for them in the textbook. I'm not going to cover each of these in the video, but please ensure you're familiar and comfortable with that content. I provided an example on this slide using vitamin D. A few roles in the body are related to bone health, that it helps maintain blood calcium levels and regulates cell growth and development. Good food sources are fatty fish, eggs, and fortified foods, and complications could include rickets if not enough is consumed, and calcium deposits in organs if there is too much consumed. Now, a sound definition of vitamins is that they are essential organic, which means that they contain carbon, organic substances needed in small amounts in the dietary pattern for normal function, growth, and maintenance of the body. There are several requirements for a substance to be classified as a vitamin. First, the body must be unable to synthesize enough of the vitamin to maintain your health. Second, if the vitamin is missing from your diet over a period of time, a deficiency or deficiency symptoms may arise. And the third, if the compound is reintroduced in the diet, the deficiency symptoms are reversed. Now, I put a picture of Dr. Joseph Goldberger on this slide for a particular reason. He was a physician, and in 1914, he began to research pellagra, which is a disease that caused what doctors called the 4 Ds: diarrhea, dementia, dermatitis, or skin rashes, and death. He set out to prove that pellagra was not caused by a germ, but by a nutritional deficiency. And I've provided more information on this within Canvas, and I encourage you to view it. It's actually a very horrific but amazingly interesting story. And it did lead to the discovery of the vitamin niacin. Now, as humans, we all require the same essential vitamins, but various factors like your age, sex, and health status can impact individual vitamin requirements. We'll discuss this in more detail later in the semester, in particular when we get to the chapters that cover life cycle nutrition. Our vitamin requirements are actually small, and more does not always mean better, but each is essential for one or more functions in the body. We must supply vitamins with our diet because our bodies either can't produce them or cannot produce them in sufficient amounts needed. Now, there are always exceptions. And there are a few with vitamins, like vitamin A, which can be synthesized from certain plant pigments, vitamin D, which can be synthesized if our skin is exposed to adequate sunlight, and vitamin K, biotin, and others that can be synthesized by bacteria in the GI tract, and niacin, which is synthesized from the amino acid tryptophan. There are 2 broad classes of vitamins I want you to remember based on the vitamin's solubility. There are fat-soluble vitamins and water-soluble vitamins. Fat-soluble are vitamins A, D, E, and K, and they dissolve in fat and are absorbed in the presence of dietary fat. These are mostly stored in the liver or fatty tissues and are not readily excreted from the body. Therefore, toxicity is a greater risk with the fat-soluble vitamins. It's important to note that anything that interferes with normal fat digestion and absorption, such as cystic fibrosis, certain medications, or certain GI disorders, they may also interfere with the absorption of fat-soluble vitamins. Now, the water-soluble vitamins dissolve in water and consist of the B vitamins and vitamin C. Do make note that there are 8 different B vitamins: thiamine, riboflavin, niacin, pantothenic acid, biotin, vitamin B6, folate, and vitamin B12. When water-soluble vitamins are consumed and released from food, they are transported to the liver and distributed to body tissues. These are much more readily excreted from the body than the fat-soluble vitamins. And when tissue saturation occurs, meaning vitamin stores in body tissues are full, the rate of excretion and elimination via the kidneys and urine is increased. So, just to reiterate, be sure to read all about the fat and water soluble vitamins in Chapter 8. Know some characteristics of each, including their roles in the body, food sources for each, and what might occur if you have a deficiency or a toxicity of a particular vitamin. If you get into the chapter and realize you have questions about any of these vitamins, please reach out and we can definitely discuss these.